Hello and welcome to today's lesson on insulation, which is found in the energy topic of GCSE Separate Science and GCSE Combined Science Physics. So in today's lesson we're going to look at how insulation works. So if we're successful and we learn in today's lesson, we should be able to define what insulation is, describe how thermal insulation has a low thermal conductivity, and examine the effect of thermal insulation on hot objects, which links in the following part of the AQA GCSE Physics specification 4.2.1 energy transfers, and links into the idea of insulation and energy transfer. So in an energy system, energy cannot be created or destroyed. It can be transferred usefully, stored or dissipated. Now in a closed system we assume that energy flows between stores. Now the process of energy change in stores is called doing work. Now in the universe, when energy is transferred, there is always some energy dissipated to the surroundings. So when work is done, you get something what we call waste energy. Now when energy is dissipated, it is actually stored in less useful ways. So to dissipate energy means to make it spread out, which we commonly call waste energy. Now it's important to note that in most examples the waste energy goes to the internal energy of the surroundings. So what we do is, in the universe we use thermal insulation to reduce this dissipation to the internal energy store of the surroundings. This means that when there is no work done, that there is very little energy lost or gained by a store. So what this means is it prevents effective heat transfer to the internal energy store of the surroundings. In layman's terms, this means if an object is hot, it will remain hot, and if the object is cold, it will remain cold, as very little energy is lost out of the store. Now thermal insulation can be found in many different places. For example, double glazing is an example of thermal insulation. Cavity wall insulation is an example of thermal insulation. Human body hair is an example of thermal insulation. Coats and jumpers are an example of thermal insulation. Now to understand how materials can be thermal insulators, we've got to consider how energy will transfer across a material. Now energy will transfer across a material by the process of conduction. Therefore, thermal energy or heat will transfer across a solid material via the process of conduction. The faster the energy transfer, the better the thermal conductor. The slower the energy transfer, the better the thermal insulator. Now the rate of energy transfer across a material is called the thermal conductivity. Now all materials have a value of thermal conductivity. The higher the thermal conductivity, the better the conductor, so the worse the insulator, because the energy is transferring across the material more quickly. So the lower the thermal conductivity, the better the thermal insulator, as energy is transferring more slowly. So in the example to the right, the best thermal insulator is polyurethane foam, as it has the lowest thermal conductivity. Now the energy transfers, like we mentioned before, across a material via conduction. Now the greater the amount of material, the longer it takes for the energy to transfer out of the material, because the greater the amount of material, the further the energy will have to travel across to get out of the material, increasing the time in which it takes, so lowering that conductivity. So another factor which affects the rate of energy transfer is the thickness of the material. So there are two factors which affect how good a thermal insulator a material is: thermal conductivity and thickness. The lower the thermal conductivity of the material, the better the thermal insulator, and the thicker the material, the better the thermal insulator the material is. So to clarify, thermal energy is transferred from a hot object to the internal energy store of the surrounding, and the energy is transferred through a material by conduction. The thermal conductivity of a material is a measure of how quickly conduction occurs. The higher the thermal conductivity, the higher the rate of energy transfer, the worse the insulator. Two factors affect how good a thermal insulator a material is: its thermal conductivity and its thickness. Now it's important to remember that even though thermal insulation minimizes heat transfer, it does not completely stop heat transfer. So consider thermal insulation as someone it's like getting stuck in the mud. It's something which slows down energy transfer. So like a person getting stuck in the mud, energy can be stuck inside a solid insulator. Now eventually the person gets out of the mud but has been slowed down, and eventually energy gets out of a solid insulator but has taken longer than it should do. Now the person will get out of the mud by walking through the mud, whilst energy gets out of a solid insulator by the process of conduction. So to summarize what we've learned in today's lesson, energy can be transferred, usefully stored or dissipated, but cannot be created, cannot be destroyed. So students should be able to describe with examples where there are energy transfers in a closed system that there is no net change to the total energy. Most insulators work as they have a low thermal conductivity, as it reduces the transfer of energy by conduction across a material. Now in addition to that, you should be able to describe with examples how in all systems they will change when energy is dissipated, so it's stored in less useful ways. This energy is often being described as wasted. Now thermal insulation is a material which reduces heat transfer in a substance. The best thermal insulators are materials which slow down heat transfer a lot. So most thermal insulators work as they have a low thermal conductivity, as it reduces the transfer of energy by conduction across the material. You should be able to explain ways of reducing unwanted energy transfers, for example through the use of lubrication and the use of thermal insulation. The idea that the higher the thermal conductivity of a material, the higher the rate of energy transfer by conduction across the material. And you should be able to describe how the rate of cooling of a building is affected by the thickness and the thermal conductivity of its walls. So if you've been successful and you've learned in today's lesson, you should be able to define what thermal insulation is, describe how thermal insulation has a low thermal conductivity, and examine the effect of thermal insulation on hot objects. I hope you've enjoyed today's lesson looking at insulation in the energy topic of GCSE Separate Science and GCSE Combined Science. Thank you very much for listening, and have a lovely day.